So hello everyone, great that you are here. Welcome to our session Enhancing Interoperability of Open Table Formats with Apache XTable. So how many of you have ever been in a situation that they had to convert from one format to the other, let's say from Hoodie to Iceberg, and ask themselves, how can I do this most efficiently with least compute and storage overhead? In today's session, we will show you a solution to this based on Apache XTable. Presenting for you today are Matthias and me. I'm Steven. Both of us are solutions architect with AWS, focusing on data analytics and data platform topics. In the next 25 to roughly 30 minutes, our agenda is as follows. First, we will be speaking about why do we actually want to convert between open table formats. What's the reason, what's the motivation and the use case behind. Then we will give an introduction to Apache XTable, explaining the project in a nutshell. And then, coming to the main part of our presentation, we will give you 3 example use cases for OTF conversion using Apache XTable and how you could get started with them in practice. With that, without further ado, let's jump right into the topic and speak about why. Why do we actually need to convert between OTFs? Now, first of all, one of the reasons being, you might run a data platform comprising of multiple analytical services with a varying level of support for a particular OTF. Your data transformation engine might work good with format A, whereas your serving engine better with different, and you need to combine it in order to make the best out of your services and the investment into these. Secondly, you might go through a conversion step because you migrate from one format to the other, because you want to modernize or you switch technologies, and as part of this technology switch, you need to adopt a different format to cater for the needs or specificities of your future platform. And lastly, you might be confronted with the fact that you just want to combine multiple OTFs in a single data pipeline across the various steps of it. For instance, you might face or be in a situation that for a particular use case, you started using Hoodie for the ingestion, but figure out that for serving and queries, end user queries, in the end, Iceberg might be better, and you need to have a way to converting in between the formats in place. However, historically, right, and when you do it in a naive way, there's a challenges converting between OTFs. First of all, you might if you just write out OTF in format 1 and B, so like in Hoodie and Iceberg, you would just be duplicating data sets. Or you might be, if you want to convert, be required to reread an entire data set, which could be gigabytes, terabytes, so depending how large your data real estate is, and then rewrite it out. And out of this, there's implications. For instance, you will encounter with this naive way of having compute overhead for the rewriting, you will have then storage overhead for the duplicate data, and you have management overhead because you need to keep those multiple physical replicas in sync, right? And always ensuring that they give the same view on the underlying data. And all of that is something that you actually want to avoid. Hence, the industry, open source space, are currently working on multi-format compatibility and solutions to that. And Apache XTable is one novel solution in this space. It's an incubating Apache project donated to the Apache Foundation by OneHouse and was previously called OneTable. XTable in essence allows for the conversion between open table formats from Iceberg to Hoodie, Delta to Iceberg, and so forth. And it is great because it keeps the metadata layer, it translates the metadata and keeps the data layer unchanged, just reuses them. In an example, it looks as follows. Assuming you want to convert from Delta to Iceberg, you would just, with XTable, which is by the way shipped as a Java executable, convert from the Delta metadata to the Iceberg data, added additionally on a data store, but keep the data files unchanged and reuse them. Hence, it's efficient because you have less storage overhead or no storage overhead because you just can reuse the data files. Because all of you, or many of you, are practitioners, let us look into how would we actually invoke XTable. As I said before, it's a Java executable. I mean, here in this case, it's a utilities 01 jar called, and you would just invoke it with your Java virtual machine and pass a dataset configuration to it. Dataset configuration in a minimal form could look as follows. Again, in our case of converting Delta to Iceberg. So we would have delta as a source format, then we can specify a list of target formats. You can convert from to one to many targets formats. By the way, right now supported are delta, iceberg, and hoodie for source as well as target format. And then you specify a list of your physical data sets which you want to convert. And then you kick it off, and XTable translates the metadata layer. But I mean, as you see, shipped as a Java executable, there's only your creativity is the limit. You can think about many ways of using XTable and deploying it to your data platform, with Java being a somewhat universal platform. And hence we will be giving you 3 example use cases for XTable, and it's just 3, there are many more, so that you understand how could I really use this in practice. The first one is invoking XTable in a data pipeline on Apache Airflow. For those who don't know, Apache Airflow is a open source project also, and it's a orchestration tool, orchestration engine for your data pipelines. And you might have the situation that you have a data pipeline which runs in the night or on a scheduled basis, or is even event-based triggered. And in this data pipeline, you create data sets in a certain source format. For instance, here, as shown here on the right-hand side, you have a directed acyclic graph DAG on Airflow, where you invoke your transformation engine to create the source data set. For instance, with Spark here, represented through Spark operator, which calls your Spark job, which in the end might write a delta table. But then you say, okay, actually, I don't not only want to have this data set available in this source format, but also in another format. So why not calling the XTable on Airflow in the DAG as well, and do this in a way that avoids data duplication. And for this, we thought about why couldn't we run XTable on the Airflow executor and wrap it with a XTable operator. So an operator on Airflow is a reusable piece of code which you can, there's standard ones, you can write your own ones, and you can use it across data pipelines for centralizing the steps to invoke an engine, the steps to run a SQL on a database, to modularize and reuse, create reusable pieces of transformation logic for your data pipeline. And of course, you can run XTable as well as such. And hence, we looked into how would we design an XTable operator, and you'll see this in a second in practice. And by the way, all of that is shipped also through a sample code repository on GitHub. You will get the links in the end so that you can try it out yourself, everything that we were showing, or just use the code to create your own solution and create, let's say, derived content from it. So, and we created a sample XTable operator for which looks as follows. It has a dataset config representing the data config file that XTable has, where we have a source format, target format, and datasets, right? And through this, I think it's quite easy to run XTable on the Airflow. Of course, you need to deploy it somewhere, the jar file deployed to Airflow executor as well. We will show you in a second how we did this in our example, but it ultimately depends also on the way you deploy Airflow and run Airflow, whether it's self-hosted, managed service or something else. With that, diving into this, handing over to Matthias. Please take it from here and get started with our first demo, and then look into also how we deployed it in practice.
Hi all, and thank you, Stefan, so far. So we want to present 3 use cases here today. 2 solutions for that have already been published on GitHub, and these are also the ones I'm going to dive deeper into here today. So using AWS services, this is how an architecture with Apache Airflow then would look like. We are using MWAA, Amazon Managed Workflows for Apache Airflow, as our Airflow environment, and the Python XTable operator and XTable executable are stored on S3 here and get sideloaded into our Apache Airflow environment. S3, for those of you who don't know, is just a simple cloud object storage for example, to store files. MWAA here then triggers based on our example DAG definition, first the data generation with Apache Spark here in our example, second the metadata translation with XTable itself, and third an update of a Redshift materialized view. Not visible here in this architecture, but we will walk through this soon as part of our demo. On the right, you can find the blog post and source code on GitHub, which describes the setup and lets you easily re-implement everything. But first, let's see this firsthand. It's demo time. By the way, I ran the steps some time in the past so that we can look at the results without having to wait too long today. First of all, let's look at the XTable application itself. It's written in Java and its main function can be called via the command line like the following. Java -jar, then the bundle, dataset config, myconfig YAML. And as you can see, it errored out here. The reason is that I didn't create the data sets here locally on my laptop, but the configuration itself pretty straightforward. Source format Iceberg, target formats here we defined hoodie and delta. Just for you to see how you could use the XTable executable also in your Java application or with the Java command line program itself. All right, before we dive deeper into our solution, let's take a look at the Airflow environment. The end solution then would look like this. Our pipeline is split into the 3 steps we already defined: data generation, XTable invocation, downstream data usage with Redshift. But how did we get to that? Let's get back into the code. We defined our DAG here, the typical pipeline definition format in Airflow. And in this demo, we first generate some data and write it to S3. We are using a glue job here. AWS Glue is a serverless data integration service that makes data discovery, preparation, and integration simpler and faster. In your data pipeline, this step in your DAG could either be some data ingestion, curation, or any other data change or creation operation. Second, we call the XTable Airflow operator, more on this later, to translate our data lake to the Iceberg format. And third, we use the data in a downstream analytical service like Redshift by updating a Redshift materialized view. Before we can start our new XTable infused data pipeline, let's first take a look at one more component we have prepared for this demo setup. We also generated some test data for a data lake in S3 and in the Delta Lake format. As we can see, there are a couple of folders here, don't get irritated. The one relevant right now is the curated sales one. And as we can see, it's in the Delta Lake format. We can see the data here and the metadata. We can already see the target metadata in our Iceberg format. That's because I already executed it sometime in the past to set this whole thing up. But right now, with everything set up, the lakehouse itself, our DAG definition, we can give the whole thing a spin. Let's go. All right, while this executes, let's look at the details. Everything would be kind of pretty straightforward, right? Just execute XTable in our Airflow pipeline. Well, not so fast. Couple of challenges here. We need to get the XTable written in Java into our Airflow executor. So we need to get that somehow in there. We also need to install Java in the executor because, to execute a Java library, you need Java. And we also need a Python wrapper to call it from our Airflow operator definition. The most common way to write an Airflow operator is in Python. And from Python, we then need to call some Python functions, right? Few. As of right now, additionally, you also have to build the XTable jar from sources. There is no published bundled library as we need it for our operator yet. But we simplified that step a little bit by providing you a build script here, just calling Docker here, and a Docker file, right, which packages the jar into an Airflow operator. So we are not building a Docker image here. We are just using Docker as our common build environment so that you can build the package independent of the operating system. You can then simply upload this operator into your Airflow environment. So in the build script here, we see that our destination is an out tar archive. The extracted archive then looks like this. The operator here bundled with the jars and the Python wrapper we can have a detailed look in a minute. Then also in an example DAG, the requirements txt file, so the Python requirements we need to install in our Airflow environment, and also the startup script where we install Java 11. All right, now we have seen how we eased up the build, the packaging step a little bit. Let's dive deeper into the operator itself. We built a little Python wrapper for that. Here with JPipe, we just start a JVM in the background, and then we can call Java classes directly out of Python. Really cool, by the way. The JPipe library is a common and community-backed Python JVM execution environment library. And then a call to XTable looks as simple as that, right? In the operator itself, we are just doing some configurations with the config YAML we already saw, for example, and then we can just call this little wrapper file with command.sync. All right, when we navigate back into our Airflow UI, we see, okay, the pipeline is still running. Then maybe in the meantime, we can take a look at the output itself. We already said that we are updating a Redshift materialized view. That's the Redshift query editor right here, and we can run a query onto our Iceberg data here. If we do that, we can see the data got queried. Also in our data lake, we already saw the metadata folder, but after a pipeline run, it should now be updated and have the same state as our delta log metadata. We also configured XTable to register a new table in the Glue data catalog. When we take a look here, sales created, that's our table type Iceberg, and hopefully the metadata location got updated to the newest versions. All right, nope. Yeah, it ran through all three pipeline steps, success, great. Great stuff so far, but we could now consequently adjust each data pipeline to include the translation to other table formats. In a real world setup, on the other hand, you would have many data pipelines. So already a high effort to adjust each and every one of those. I would also kind of expect of an advanced data platform that I could write data in a format and the platform manages the translation to other formats itself. That's why we implemented a second solution. Another possibility to invoke XTable is through a background conversion mechanism, which we deploy in parallel to our pipelines and don't need to touch our existing pipelines at all. Use cases for this could be a data pipeline with requirements to data freshness. All right, we would not want to add yet another pipeline step to that and add more latency. Also, if we have many data pipelines, as I already said, we would have to adjust each and every one of those, also not preferable, or data pipelines without the ability to run XTable. We have seen XTable has some requirements and not every environment can execute XTable out of the box. Okay, now we have already seen how to package and execute XTable in an Airflow data pipeline, right? But transitioning that into any other compute environment should not be too hard. The challenge we still have to solve now is on what input event we will act upon, like each and every data write, like incoming data write. Could be a lot of writes if we have a high frequency of writes incoming, or maybe better periodically execute XTable every X minutes. And we will also need to solve how to discover all of those tables we want to convert. In our solution, therefore, we are adding one more architectural component, a data catalog. In the catalog, we are tagging the tables in that way so that the table detection component with XTable knows which tables to pick up and then is able to translate to another format. So in a nutshell, our solution with AWS services can look like this. An AWS Lambda function, let's call it the detection function, gets triggered every X minutes by EventBridge. This covers tables in the Glue data catalog, reads all the necessary metadata about the table like storage location, source format, and target format, and then calls another Lambda function, let's call it the conversion function, where then actually XTable converts the OTF metadata into our other format. AWS Lambda, by the way, is a serverless compute environment where you only have to define your function code along some configuration options. Amazon EventBridge, of those of you who don't know, is a serverless event bus that helps you receive, filter, and transform, route, and deliver events, but can also, and that's what we are using here, generate scheduled events. On the right, you can find the same QR code. To GitHub again, we wrote a CDK stack in this solution so that you can deploy the whole solution with nearly no time effort. CDK automatically builds a Docker image Lambda function, including XTable, so a Lambda based on the Docker image we already saw in the last solution, but with some edits. The call itself looks pretty similar, but let's see this in real time. Let's take a look into the AWS console again. I deployed some things again some time ago so that we can have a look at the outcome right away. All right, we registered and configured our data catalog. Here the table hoodie table in the Glue data catalog, and we defined the table properties, XTable table type and XTable target formats. Our Lambda then picks these up and asynchronously triggers the other Lambda. So our detector function picks these up. We can give the whole thing here a test event to start it. This one triggers the second Lambda, our converter Lambda, which now does the XTable translation. We have our lakehouse set up here in S3, this time the hoodie table. We can see here's our hoodie metadata along our data files. When we take a look at our conversion output logs, let's see. Yep, that's not the latest one. Whoops, now this one just got executed. Everything looks fine, no error. It took about 7 seconds. Execution time is dependent on the diff, by the way, between the two metadata states. As we can see in the output here in our lakehouse, the metadata folder got created or updated. Let's take a real quick look into the function itself. The detector here loops through our Glue data catalog, then constructs an event out of this if there is the XTable target format and XTable table type in the parameters, as we have already seen in the Glue console. It then sends this event to our second Lambda, the converter function. Converter function, again with our Python wrapper, looks really simple. XTable.sync, write configuration paths, and that's it. So thank you for your time, and passing back to my colleague Stefan.
So thanks, Matthias, really great. Hope this was already very insightful for all of you. We now look into our last use cases, how to build a reactive background conversion mechanism. It's a permutation from the previous case, but also still quite different. So assuming you want to have low latency and high data freshness use cases, you have a table which is constantly updated in the source format, and you want to have it in the target format after conversions also available as soon as possible. For instance, streaming use case. Or you don't have a central data catalog in place which you can use to identify the tables to convert, and you need a different way. And then we thought about how would it make sense to design a mechanism which is automatically triggered as at the point that changes to the source table are done, as the metadata on the source table is done, and implicitly then automatically start without any scheduling mechanism or anything, just start right away the conversion. One thing that we figured is how do we design this this notification and this event-driven mechanism, because what we actually want is to have the conversion kick in, start right as the new metadata or changes are written to the source table on the storage. And how would we design this control loop, and how do we start in the conversion? So, and basically what we want to do is transformation engine writes to our data lake, to the source table, and then we need something that triggers XTable in order to do the conversion. And the solution that we have been building is, well, we thought about, then let's use the power of the managed cloud service to accomplish this. Here, example on how to implement such a reactive event-based mechanism on AWS. And of course, I mean, there's also different ways to do this also on other platforms. So we have again here the transformation engine writing the table to our S3 data lake. So assuming that the data lake is based on the S3 object storage. And then the question is, how do we trigger the conversion based on changes to the OTF table? And for this, we want to leverage the power of a managed object store, which can emit events as files or objects on its are changed, added, or deleted. So what we did is to use the S3 object events, which you configure and activate, which emit event to a messaging system, in our case here Amazon SNS, and then use this object event to later, eventually in the next step, trigger XTable. We did it in a way that we also filter on the specific object, so we don't do this in each and every object. We only filter on specific metadata, because we know for instance, if a Delta table, we know that something in the Delta log folder is going to change. So we just configure this mechanism to trigger on that. We emit the event, this change event, to the messaging system, and then what we do is invoke the Lambda function. So we again reusing the Lambda function from the previous example and use cases which Matthias has shown, and then run the conversion. All of that is designed completely reactive, right? No scheduled or any scheduled control loop, and everything also made in a way that's completely serverless, pay as you go, right? If there's no changes to the source table, no component runs. And this is really great how you could build a reactive conversion mechanism, for instance, for a streaming use case where we don't have a specific point in time where you could invoke a conversion step, like in a synchronous data pipeline, and where you want to do something in the background just for that. With that, let's wrap up our session. We've learned Apache XTable allows for conversion between open table formats, for instance, from Delta to Iceberg. There's many use cases for XTable. We have shown you 3, but with your creativity, you can come up for sure with many others. We have seen how you could invoke it synchronously in a data pipeline or processing job. We have seen as an example with on Apache Airflow. But also we have seen how to build an asynchronous mechanism using a serverless function, or you could even think about running XTable in a container as well. I hope you enjoyed the session. Please check out our sample code repository on GitHub. Here the QR code, but you also get the explicit link in the handout. Showing it for a second. Thanks all for your attendance. Enjoy the conference and the remainder of the sessions, and have a nice day.